All right, for the next page here, starting with number 12, I think this is the most challenging problem. And the way to get through this is to rely on setting up this equation every time. So starting with, let's see, if we want to try to figure out what is f of 1, we might not, f of negative 1, we might not be able to start there, but let's just try. So my goal is to start, maybe try to fill this in. Okay, well, f of negative 1, the way this function works, I've got g of f of negative 1 equals h of negative 1. H of negative 1 is equal to 1, right? So now we know 1 equals g of f of negative 1. Okay, here's where things get kind of tricky. F of negative 1 is an input, right? So let me move my work down here. 1 equals g of f of negative 1. Whatever answer you get from f of negative 1, whatever that input is, it's got to make sure that g equals 1. So let's go look at g's table. G is equal to 1 when the input is 2. So what does that mean? Well, g is equal to 1 when the input's 2. That means that f of negative 1 has to equal 2 to make this relationship work out. So I finally get down to f of negative 1 equals 2. F is the hardest one, I think, because you're kind of working backwards. So, okay, so let's try f of 0. Let's try the same thing. So I'm going to erase my work for here. All right, so let's start this over and say we want f of 0, right? F of 0. So fill in the rest of the definition. We've got g of f of 0 is supposed to equal h of 0. Okay, so what can we fill in? We're trying to figure out f of 0. H of 0, we have that. When x is 0, what is h? It's positive 2. So now I know 2 equals g of f of 0. Okay, 2 is an output of g. What does the input have to be to get an output of 2? Let's go down to g. When g's output is 2, its input is 3. That means that f of 0 has to equal 3. Okay, let's look at, I'm going to leave that up. Let's look at g of 1. We're supposed to do g of 1. Well, according to our definition, we don't really have, that doesn't mean g of f of 1. That means g of f of x is somehow going to equal g of 1. So what is that equal to? I don't know what x value makes that happen yet just by looking at the 1. So right now it's like g of 1. Well, normally when I say that's h of something, I need to know what x value makes that happen. So let's go back and look. When is f of x equal to 1? What input makes that happen? So go to f's graph. When is f of x equal to 1? When x equals 2. Okay, so what does that mean? It means now we know that the x input that we're supposed to be doing is 2. So now it's h of 2 equals g of 1, or in other words, equals g of f of 2, whatever. And what's h of 2? H of 2 is negative 2. So g of 1 equals negative 2. Again, these are confusing. So if you're feeling like, what is happening? We will go through these again. You might kind of want to rework through them. I will give you new tables and we'll practice them again. F of x and g of x are the hardest two tables to fill out of these three because we're kind of working backwards. H of x is actually a little bit easier because you're just plugging right into the formula that you're given. So I want to find h of negative 2. So h of negative 2 is supposed to equal g of f of negative 2, right? Because whatever x goes in here for h, that's the x that gets plugged into f. H of negative 2, I don't know. F of negative 2, I have. When the input's negative 2, the output's 4. When the input of g is 4, the output is 0. Therefore, h of negative 2 is 0. What about h of 1? set it up. H of 1 equals g of f of 1. We don't know h of 1. We do know f of 1. When the input's 1, the output is 5. Go to g. When the input is 5, the output is negative 1. So therefore, h of 1 is equal to negative 1. Tables are tricky. We're going to have tables like this on our AP Pre-Calc test. You're definitely going to have them in AP Calculus next year, whether you do AB or BC. So we will keep practicing these. I know, like I said, I think this is the hardest problem, the most confusing problem. Okay, on 13, use the figure to calculate the following. So we might have to estimate a little bit. If we're off by tenths, that's okay. Remember the way this works. Start on the inside and simplify from there. What is f of 1? So when the input is 1, and be careful for which graph you're on. F is the absolute value looking one. When x is 1, where do we land on f? It looks like we landed about 3. So now the problem is just f of 3. When the input is 3, where do you land on f? It kind of looks to be about 2. So again, if you're saying it's 2.1 or it's 1.9, that's fine. Okay, g of 1. So when the input's 1, where do you land on g? Oh, you know what? I just said be careful and I landed on the wrong thing. Go back. Sorry, guys. Made my own mistake. Okay, here's f. Let me color code these. You might want to do the same. Highlight f. Highlight g in a different color or something. Okay, let's try this again. When the input's 1, where do we land on f? 2. Now it's f of 2. When the input is 2, where do we land on f? At the top, 4. Okay, sorry about that. What about part B? When we input 1, where do we land on g, which is this one up here? That's 3. So now this is g of 3. When we input 3, where do we land? I'm going to call that about 1. Okay, starting on g. So we're going to have f of what? What is g of 2? So when I'm at 2, where do I land on g? I'm going to say it's about 2. Go to input 2. Where do you land on f? You land at 4. Start on f this time so that we get g of something. Input 2. Where do you land on f? You land at 4. Input 4. Where do you land on g? You land at 0. Now, E and F, so far we've been finding y values, right? These are all outputs, or these are all y values. Now we're turning it around. Find x such that f of g of x equals 0. We have to work backwards here, okay? When does f of g of x equal 0? So let's see. When does f of something equal 0? What are the inputs that we need to have to make f 0? So f is 0 when the input is 0 and when the input is 4. Okay, now what x value makes that happen? Well, the input is g of x. So instead of input, when is g of x equal to 0? And when is g of x equal to 4? G of x is equal to 0 at x equals 4. G of x is equal to 4 when x equals 0. So this is E. X equals 4 and x equals 0. Same thing for f. Now the outer function is g. So g of something equals 0. Determine what inputs make g of x equal to 0. There's only one input that makes g of x equal to 0. That's when the input is 4. And the inner function here is f of x. So when is f of x equal to 4? That happens only once at x equals 2. Okay, so x equals 2 for this part. More graphing. Let f of x and g of x be the functions from problem 13. So I'm going to zoom this out a little bit. Graph the function. So when we graph this, let's keep our coordinates the same. Let's make this let's make this 0, 1, 2, 3, 4 on the y-axis, and 1, 2, 3, 4. So we're basically in the first quadrant, right? F of g of x. So I would make a little chart here. When x is something, what is f of g of x? All right. Now, actually, did we do any of these values? We do have some of these answers. F of g of 2 is 4. So we could plot 2, 4. That's the only one we have, I guess. Okay, so we know that that should be a point up there. But what about the others? So start with 0. F of what? What's g of 0? 4. What's f of 4? 0. So we should have a 0, 0 point. Plug in 1. What's g of 1? G of 1 is 3. What's f of 3? F of 3 is, I'm going to call it 2. We already did 2, 4. I got 2, 4 from part C above. Okay, and then what about 3? So g of 3 is 1. Find f of 1, that's 2. So 3, 2. And plug in 4. G of 4 is 0. F of 0 is 0. So we get a graph that looks just like f basically. Go the other way. When I'm graphing weird things, I'm a big fan of tables here. So let's start with 0. G of what? When we plug in 0 for f, we get 0. So what's g of 0? 4. Plug in 1. What's f of 1? F of 1 is 2. What's g of 2? 2. So 1, 2. Plug in 2. When you plug 2 into f, you get 4. When you plug 4 into g, you get 0. Plug in 3. You can probably guess that the other 2 points are going to be like this, but let's just confirm. Plug in 3. So plug that into f, you get 2. And g of 2 is 2. And plug in 4. When you plug 4 into f, you get 0. And yeah, g of 0 is 4. Connect those. On what intervals is f of g of x increasing? That's the first graph, right? So where's the interval where the graph is increasing? 0 to 2, never including the endpoints. When is g of f of x decreasing? So go to the blue graph. That's also 0 to 2. Okay, last page. Find f of 1. So remember, the way that this works, we have a piecewise function. We start with f of 1, figure out what that's going to be. So first of all, plug it into the correct piece. An input of 1 falls right here, so we should be on the middle branch. 3 times 1 plus 1. So really this is asking us to find f of 4. 4 is in the bottom section, x greater than or equal to 2. So that's 16 minus 3. So f of 1 is equal to 13. All right, final set of problems. Find f of g of x and find g of f of x if defined. Now, this box here is a separate thing. This is domain and range for each of these. So we're just going to do f of g of x and g of f of x off to the side. Let's do domain and range first. These are two linear functions. So domain and range is all reals all the way around. And f of g of x, so f of x minus 1, is equal to x minus 1 plus 1. I should say minus. So that simplifies to x. Do we have any restrictions? No. Remember, I want you guys to get in the habit of always writing a domain anytime you create a new function. Go the other way. G of what's f of x? X plus 1. G's equation is x minus 1, so we're going to put in x plus 1 minus 1. That's also x defined for all real numbers. No restriction on the inner function, no restriction on the final answer. The next two functions are all linear, so again, all reals all across the board. F of g of x means f of 1 minus x. That's 2 times 1 minus x minus 5. That's 2 minus 2x minus 5. That's negative 2x minus 3. All real numbers. G of 2x minus 5, that's g of f of x. It's 1 minus, make sure you put parentheses, 2x minus 5. You're subbing in for this variable here. That's 1 minus 2x plus 5. That's 6 minus 2x, or negative 2x plus 6. All real numbers again. We have a quadratic. So the domain for f is all reals, but it's quadratic. Remember, it's one of these. Oh, it should be going through 0. So its range is 0 to infinity. Linear function g is all reals for both domain and range. F of g of x is equal to 1 minus x, the quantity squared. Now, you can simplify that if you want to, 1 minus 2x plus x squared, or you could just say, that's it, all real numbers. G of f of x is g of x squared. Instead of 1 minus x, 1 minus x squared, all real numbers for that domain. For number 4, we're back to linear, all reals for f. Now 5 is linear, but it's a horizontal line, so all reals for its domain, but just the number 5 for its range. F of g of x is really just f of 5. 2 times 5 is 10, minus 5 is 5. No restrictions for that. You can write all reals if you want to. Might as well. Even though that's an evaluation piece, this is still our function. So that's still what it would look like. And then g of 2x minus 5. Now, what do? The function is just 5. That just means there's no x to plug into. So even if you're composing those two functions, it's still just a horizontal line at 5. And you can still say all real numbers. Domain for f's quadratic is all real numbers. Range is not 0 to infinity. It's got a high, its lowest point is 5, and then it goes up from there. So 5 to infinity. We have a little bit of work to do for g, right? 1 minus x is greater than or equal to 0, so 1 is greater than or equal to x. In other words, x is less than or equal to 1. So negative infinity to 1. What about the range of this thing? If we had to graph this, it has not been shifted vertically, so it's going to be 0 to infinity. It's just that it underwent a y-axis reflection. Okay, so f of g of x, f of the square root of 1 minus x. Remember, we have a domain restriction, x less than or equal to 1. So this has to make it to our final answer. I'm squaring a square root and then adding 5. Squaring a square root does not make absolute value. That's the other way around. Square root of this is 1 minus x in an absolute value. Just squaring something underneath the square root, it's just going to be 1 minus x. So I get 4 minus x, I get 6 minus x. 1 plus 5 is 6, definitely. I get 6 minus x, but remember, because of the initial square root in the problem, even though it's gone now, x is still only less than or equal to 1. That's why we take the time to do domain. G of x squared plus 5 will be the square root of 1 minus the quantity, x squared plus 5. This becomes what? 1 minus x squared minus 5, so negative x squared minus 4. Now this graph can't exist because this negative x squared minus 4 is always negative. Think about that graph. Looks like that. You'll never be able to square root any of those outputs. So g of f of x actually doesn't exist. Okay, that finishes out our packet. Again, this can be hard to wrap your brain around some of these questions. So please come into office hours if you have any questions or stop by during flex. We will be practicing some more tomorrow.